And I'm going to switch on this recording. All right. So this is episode 35 of the Building Automation Monthly podcast, and I am Phil Zito, the owner of Building Automation Monthly and the podcast host, I guess you would say, for tonight's podcast. And this is something a little different that I'm trying, where I'm recording podcasts on Facebook Live while also recording them on Audacity and also putting them on YouTube. So last time didn't go so well. This one I think is going to go a lot better. All right, so in today's episode, I'm going to be discussing the concept of IT architecture. And what is IT architecture? Well, IT architecture is all of the bits and pieces of technology that make up information technology. And specifically today, I'm going to be focused on more of the compute technology, more of the operating systems, servers, etc. So we'll be focusing a lot on that. And throughout the rest of this series, I'll be focusing on networking, databases, cybersecurity, IoT, etc., etc. But in today's episode, I'm going to be covering clients, servers, containers, and embedded devices. So if you have not heard of these terms, by the end of this episode, you will know what these are. You'll know all the bits and pieces and intricacies of them. I'll even share some resources that I'll put in the comments, like one resource that I will share right now, which is around containers versus virtual machines. So I would encourage you to read this after the stream is over. But essentially, what's going on here is that the majority of building automation systems, they work on what's called a client-server architecture. I'm sure you've heard that at some point in your career. You've heard the term client-server architecture, but have you ever really known what that means? And what that means is that you've got a server, right? And that server is serving up resources to what's called a client. And a client machine is a machine that accesses the server. So what's going on is you've got a couple different types of servers that I'll cover a little bit later in this podcast. And these client machines will be accessing these servers. And so what a client machine consists of, at my feet here to my left, I have this about 36-inch tall computer that I built myself. And inside it, it has several different pieces to it. It has what's called a central processing unit. And what that central processing unit does is that does all of the processing of any code, of any functionality within that computer. So there's a term called digital, and what digital means is ones and zeros, ons and offs. And how computers work, right, is they send a series of ones and offs, of ones and zeros, ons and offs, to the central processing unit, which then interprets those and then turns on and off a series of transistors, and based on that makes stuff happen. And I'm not going to go any really deeper than that, but basically what happens is that these commands get stored in the memory, get funneled to the CPU that processes them, and then these commands get executed by your computer. So what's going on right there is you've got these commands being executed. Well, what would a command be, right? So let's say you want to go into your building automation system. So you open up a web browser. A lot of building automation systems nowadays are using what's called HTML5 graphics and HTML5 user interfaces. Basically, that's the latest version of HTML. HTML is hypertext markup language, which essentially, if I were to go, and unfortunately you all watching the podcast are not going to see this, or listening to the podcast aren't going to see it, but if I went here and I hit F12 for view source, you would see all this code right here, right? This is all a bunch of script language, and it's also a bunch of HTML, see? Hypertext markup language. And so what's happening is that the computer is running an application called a web browser, And that web browser is then going and calling against a server for a resource. What is that resource? Well, that resource is that HTML code I just showed you. So what happens is your client machine says, hey, Mr. Server, I need to have this resource for maybe my VAV box page, right? And so the VAV box page then is rendered in HTML, and that HTML is sent back to the client machine, to the browser, and that browser then runs some operations through the CPU and then displays that VAV box page. Bear with me a second. I'm just going to take a sip of water. So, what's going on is that you have this operating system, right? And this operating system is giving you the ability to run these applications. And these applications are running based off of stuff that is on these servers. So I mentioned you have a couple server types, and I'll get to those once again in just a second. But before I do that, I'm going to talk about the two operating systems that exist on a PC, and that is Windows and Linux. Now, most of you are probably familiar with Windows. You know, you're probably running Windows, or maybe you're running some sort of Apple operating system right now. But you're running those kind of operating systems. What you may not be familiar with is Linux. Now, Linux is a open source freeware operating system. Now, why am I talking to you about Linux? The reason I'm talking to you about Linux is because of the Internet of Things. When I talk about embedded devices a little bit later in this podcast, I'm going to be talking about devices that are running Linux operating systems. And Linux is an operating system that you're going to have to start getting very comfortable with if you're in the building automation space, because the building automation space is starting to embrace IoT controllers. And guess what operating system IoT controllers run on? They run on Linux, and you're going to have to get comfortable with interacting with those controllers. All right, so I mentioned servers, right? So servers are what host applications and host resources. So how many of you have went and probably logged into your email at least once or twice while listening to this podcast or listening to this live stream? Well, by doing that, whether it's Gmail, whether it's Outlook, no matter what it is, you're connecting to an email server. And your Outlook or your Gmail is a application. One of them is a desktop application and the other is a web-based application. But they're applications nonetheless. And so you're going and connecting to that email server, and that server is then providing you your mail, which is a resource. Well, in the building automation world, you have building automation servers, right? And those servers then act with a couple set functions. Their job are to basically summarize all the data that's coming from the supervisory devices, grab all that data, summarize it up, normalize that data, and then send it to the database. And then you connect to the server using the user interface. So you're going to use a user interface, whether that's a Java user interface, which is on some older building automation systems, or it's one of the newer ones with the HTML5, which would just be a regular web browser. You're connecting and grabbing those resources that I mentioned. So what's going on here is you're connecting to the server. Now, you've often heard folks say you shouldn't use your building automation system or your building automation server. You shouldn't use that to log into your building automation system. You should go through your client. The reason is that if you are making a call for a resource, all you're doing is you're temporarily using the memory and the CPU on your server to grab that resource, send it to the network interface card, and send it out to the client machine. Now I'm going to repeat that real quick so that everyone got that. When you are using a client machine to access a building automation server, you are going and asking that server to perform a function where it goes and temporarily uses some of the memory and CPU to then send that resource, that file, that HTML, out the network interface card to your client. However, once that's done, it's done. If you're logged into the server and you're using the server as your building automation system, graphical user interface, or GUI, then you are still using that CPU, memory, and storage, and using that network interface card. You are basically slowing down the building automation system for everyone. So that's why it's so important very rarely to use your building automation server as your graphical user interface. I've went to too many facility rooms, too many job sites where literally the building automation system is installed in the facilities office and it's under a desk and everyone logs into it. And then they all complain about how the building automation system's slow, and they all complain about how it's just not responsive. And then you look at the logs and you see that, you're sitting there live streaming videos on NFL playback from YouTube on the building automation server, and then you're complaining about the building automation server being slow while you're watching ESPN playbacks on it and doing your fantasy football or online poker or whatever. I've seen it all, and unfortunately that has a dramatic effect on the BAS, especially when a lot of remote sites are needing that BAS server. All right. So databases, right? So we talked about there's multiple types of servers. The next type of server is the database server. And what that typically is either a split server, meaning that you're communicating to the IT's database system, or that is a full server, meaning that the database software is running on the building automation server at the same time. Now, the reason why you would want to avoid that goes back to why you would want to avoid using a client machine to log on to your BAS server at the same time as well. And you want to avoid that because, once again, the database software is going to be taking resources away from your building automation system. That's why in an ideal world, you want to have separate environments for your different applications. Which brings us to the topic of virtual machines. So virtual machines allow you to emulate a full-blown physical machine on a single machine. They actually allow you to emulate multiple machines. And how they do this is they replicate the CPU, motherboard, network interface card, memory, storage, etc. And they allow you to run multiple operating systems across these different resources. So you would go and say, I'm going to give one core of the CPU and 4 gigs of RAM to VM1, and another core of the CPU and another 4 gigs of RAM to VM2. And then you're able to run multiple operating systems on virtual machines. And that's how the cloud works. The cloud is a bunch of servers that are running virtual machines on them, and you are just going and using those virtual machines, and if you need more resources, your virtual machine gets moved to a different server automatically by some software. Now, there's another technology out there right now that I posted in the comments, and I'll post this on the podcast note page as well, but that is the topic of containers. Now, what containers are, so as I mentioned, a virtual machine, that goes and that replicates the entire operating system, CPU, memory, storage, etc. A container simply allocates only what is necessary for an application to run, and it doesn't go and create a whole new virtual machine. So it's much less resource intensive, but it also shares a lot of higher level resources. So a lot of code, a lot of core PC and server code is shared, which can make big security gaps for containers, which I'm not really going to unpack, but the article I linked to goes into that. And finally, I'm going to talk about embedded devices. So some of you may have heard last Friday there was a bunch of Internet of Things devices that got hacked. And basically they really didn't get hacked. What happened is there was this malware, and it was looking for a signature of these IoT devices, right? And it was looking for certain IoT devices that it knew these IoT devices would have vulnerabilities, and it knew the default username and password. And what it did was it found these IoT devices, it used the default username and password, and if that worked, it then was able to have access to the IoT device, installed some malware, and that malware was used to then send traffic uplink towards ultimately the domain name server for Netflix and for Netflix, AWS, Twitter, and Etsy, and Shopify, I think. A bunch of different things. But basically, domain name resolution is where you go and let me show you. Actually, I'll show you. Now, once again, if you're listening to the podcast, this will be a little hard for you to follow. But if I go here and I type in ping google.com, you're going to see that google.com got resolved to 216.58.192.142. Now, how it was resolved was because of a domain name server. So what happened is there's a domain name server that takes this google.com and converts it to the IP address right here that you're seeing. Without this, you would not be able to go and communicate with google.com. So basically, the IoT hack, what that happened is all these IoT devices then were used to send a bunch of traffic uplink to this DNS server. And now, remember how I talked about how clients and servers have limited resources. They have CPU, they have memory, they have storage, they have network interface cards, right? So they can only process so much data coming to that network interface card. Well, that domain name server, it got too much data to the network interface card. The CPU couldn't handle it, and it shut down the domain server. It could not go and answer to all the machines that were requesting saying, hey, what's the IP address for Etsy or for Twitter? It couldn't answer that, and because of that, those sites were seen as offline. Well, with IoT, you're going to be running into a bunch of devices like that, a bunch of embedded IP-enabled devices, which naturally brings you to how can I make sure these things are secure? Well, with any building automation system, you're going to want to make sure that you change the default username and password, because that's how all those IoT devices were hacked, right? But with embedded devices, if you're keeping them internal to your network and you're not allowing their traffic to route outside of the network, which I'll cover this more on the networking podcast episode. But if you're not allowing that traffic to route outside through through network address translation, then that information should not be able to be accessed outside your local area network. All right, so that in a nutshell is the IT architecture for servers and client machines. So in this episode, I covered how client machines work, how they communicate, what CPU, memory, storage, network interface cards, all those things do. I went briefly over operating systems. I also talked through servers, and I talked through 4 different types of servers: virtual machines, containers, and embedded devices. With that, I'm going to pause the podcast recording, and I am now going to answer any questions from the live stream that folks may have related to anything I covered so far. So now's your chance. Ask whatever question your little heart desires, as long as it's related to IT architecture. And just so you know, it's usually a 20-second lag on stuff, sometimes 30 seconds. So if I don't answer right away, that is why. All right, either I did a really thorough job of discussing all this, or I bored everyone to tears and they've fallen asleep on their keyboards. So it's one of the two. I'll give a couple more minutes, see if anyone has questions. All right. Well, seeing no questions, I will wrap up the podcast / live stream / everything else. You can always go and ask questions after the fact in the comments section. Ask me to clarify anything, and I will definitely do that. Alrighty. Thank you very much.